Okay, let's do functions and inverses. So we're gonna start with determining the inverse of a function. So for that, so we're gonna start there. So to find the inverse of a function, what you need to do is you just need to swap the x and y. So that's all you do when you want to find the inverse of a function. Let's do it. But before that, in if the function is written in the form f of x is equals to, first rewrite it in the form y is equals to. The final answer of the function is written in the form inverse of f of x is equals to. Okay, let's start with the first one. So in the first one, as you can see, you're given a function there, 2x plus 1. You first rewrite it as y is equals to 2x plus 1, so that you know where x is, where y is, so that you can swap them. So you there is loaded as y equals to, then you swap the x and the y. So as you can see here, it was x, here's it was y, you just swap them. After that, you make y sub the formula. That is, in this case, you're gonna move the 1 to that side. Okay, let's do it for ourselves. X is equals to y plus 1. Okay, you move the 1 that side. It's x is minus 1 equals to 2y, and then divide by 2, divide by 2, divide by 2. So we're gonna have x over 2 minus 1 over 2 is equals to y. So in this form, it's mx plus c equals to y. So you can see that the gradient is 1 over 2. So another format, as you can see, y is equals to 1 over 2x plus or minus 1 over 2 in this case. Minus 1 over 2. Again, it's y equal to mx plus c. You can see it properly now. Yeah, when you separate it, you can see it clearly. When it's one thing like this, it's still correct. But then I would advise that you also use the x plus c format. Let's check the second example. Second example, already in the form y is equals to, we want to find the inverse as well. So we swap x and y there and there, and then we try to make y sub the formula. Let's do it. So x is equals to 3y squared. First step, divided by 3 on both sides. And this cancels that. Next step is to apply a square root on both sides. Now, don't forget to put plus minus. So therefore, y is plus minus square root of x over 3. In this case, it says note the A inverse gives two outputs for each input. So this means that the inverse is not a function. More about this later. Okay, now let's get to exponential functions and logs. So with logs, you need to remember that if you have something like this, you can change it to something like a is equals to log base 2 of 8, which is the same thing as 3. So yes, you can change it to that. That is, this exponent will be equals to the log of base of this and the 8 on the side. So you just need to know how to change it to that. It's like here. So it's going to be this, y is equals to log of this. Down here is the base, and then the x on the side, as you can see. Similarly, you need to know how to take it back. So if it's in the log format, you need to understand the way you're going to write it is you're going to say this is equals to this to exponent that. So you already start here, come here, and then end with that. While this side, you start here, equals to log of base here, and then lastly there. Okay, let's apply it. So there. So it's y is equals to 5 to exponent x. Find the inverse, that means we swap x and y. X is equals to 5 to exponent y. And then making y sub the formula will be this, which is y equals to log of base of that, and then the x on the side. There's the inverse function. Next one, b there. Just remove. So even here, let's swap x and y. So y is equals to 3 to 6 minus x. You swap x and y, it's going to be x equals to 3 to minus y. You make y sub the formula, it's going to be this, minus y equals to log of that, then x on the side. Now, do you want it in terms of y only? So divided by negative 1. So y equals to negative log base of 3 of x there. That's how you do that one. Next one, when you have a negative there, it just goes to c. There it is. So first write into the form y, swap the x and the y, as you can see there. And then divide by this negative first. So before you can change it to log, I'm gonna have this one divide by negative 1 first. Every single time, please do that. 4 to exponent y. Therefore, this is equals to log of base, the base 4 of negative x there. So this just means that our x will be all the negative numbers and 0, because you can't have a negative in here. So that means your x will be less or equals to 0. The other x are not going to work. Only the negatives and positive will work. Next one, example 4, moving from logs. So you're given the log 4 equation. They want you to find its inverse. So determine the equation of the inverse of. So we want the inverse, they gave us that. So first and first, write it in the form y is equals to. Then change, swap x and y, as you can see there, and then back to exponential. Remember, it's this is equals to this to exponent that every single time. So as you can see, the y base 5 or to exponent x. And therefore, there's the inverse. B. You have the original equation there, swap x and y, and then change it back to exponential. That is, this is equals to base of that all to exponent that. Then you have to divide by negative on both sides. Then you're going to have that. Next, C. You have that as the original. Sub x and y. Divide by negative after swapping x and y. So before you change it to exponential, this one you have to remove this negative, because it's not going to be accommodated. I mean, if you change it from there, it's going to be y, base of this, exponent that. Now it's lost. Where do we put it? It's like it wasn't there. So you have to remove it first. So you divide by negative on both sides first, and then you're going to change it to exponential. Therefore, this cos of this to exponent that. You can try the exercise for yourself. And we're gonna get into the graphs of a function and its inverse.